All right, I have already have started the recording. All right. So first, let's quickly go through this critical thinking. All right. Critical thinking is, I think, actually is quite important for us to do a successful analytical analysis. So there are some online resources. On Moodle, our colleague from economics, right? So they developed online module to talk about critical thinking. They have some resources you can look at, and also have some exercise for you to try. I think it's a great resource. So now, although it's optional, I strongly encourage you to try this module, complete the module. It's open to all of us. So what is critical thinking? I took some screenshot from their tutorial to quickly give you an introduction of critical thinking. Critical thinking, in other words, is a way of thinking. Or now the art of analyzing and evaluating thinking with a view to improve it. That's their definition. But in a short word, it's thinking about thinking what is a mega cognitive or higher level way of thinking skills. So in the context of university study, critical thinking is often about critiquing evidence and arguments, developing an argument that persuades. Right? And that's very useful in our daily life as well. So in the following slides, they talk about 5 elements that is involved in critical thinking. That including asking questions. Now you start with a question, right? So you ask some questions, then based on that question, you get some evidence handy. Now, whatever evidence you have, try to examine them first, right? Just to thoroughly understand the problem and have first initial understanding. Then you read it closely, that read including hear other people talk, right? So basically get opinion from other people. And then based on both evidence and what you learn from theory, let's say, right? With many times, what you read many times of theory, if it's some discipline, right? So then you construct your arguments based on what you learned, based on what you examined. And that's not the end of the story. After you have the arguments, it's very important to evaluate those arguments against certain standards. Right? Then you answer that question. Now, what our without critical thinking, what happened? Now, this is what I see. Now, we have a question. Usually, we jump to what other people tell you. Right? Not necessarily read. Just briefly get some opinion from other people. Then quickly make arguments. Then say we solve this problem. Right? So that is a typical way many of us do things without critical thinking skills. Right? But with critical thinking skills, I think you have noticed that a few important elements was missing in normal kind of way of thinking. Right? First is examining the evidence. Right? Now, that is very helpful for you to make sure you understand the scenarios very carefully. Right? Make sure you don't miss any hidden questions there. Right? And then you need to read it closely, not read it briefly or just hear opinion from a friend and you make a decision. Right? After that, with your arguments, you need to evaluate these arguments to make sure they are good ones. Right? And then on the next slides, there's some standards to thinking, evidence, and reasons. Right? So clarity is the idea or connection or the evidence or whatever you think you get information. Is it clear? Right? Is the question clear? Does it make sense? Right? Make sense. Relevance. Are the things I collected relevant to the question or topic I want to address? right? Or how relevant is it? And accuracy, is it possible? Is there any possibilities that some evidence, something I hear, may not be totally true, right? Maybe partially true. They are still valuable, but you need to keep in mind the possible caveats. And then logically, how is it related both to the question and evidence, whatever you learn, how are they related? How do they follow in a logical way? Fairness. Fairness is gave other viewpoint a fair chance to be reviewed. So you may have your own viewpoint. You think I have learned this problem already, but no, different people from different standing points, they may see things differently. Right? A good argument, a good solution of the problem will take carefully about other people's standing point. Look at the same problem from different angles, right? And breadths. Now, is there any gaps, or is there any possible things that I have missed? Right? So now we have assignment on critical thinking as well. Right? So that is your individual task to hand in at the end of the term. So basically, you are going to ask, you are going to propose an analytical plan, right? So this department store, they want to embrace the power of the mobile device. And everyone have a mobile device, right? How to utilize that to boost your business? So you will propose some arguments, right? So the key thing here is to link different parts together, right? Link what you learn about analytical tools, right? In order to utilize it, you need analytical tools. But how can be used? What kind of data do you need to make it work, right? You need to know that thoroughly. You also need to think about the contents of the business. What do they want to achieve? For department store, what is their biggest problem? What are they try to, what kind of problems they try to solve? Now that's where you can help them, right? At the same time, now mobile device, what do we do with mobile device? Right? What does that mean for both business, for how we utilize analytical tools? So connecting all these parts together, that's how you start to put together your argument, right? Then make sure your result is clear, no, relevant, right? Accurate, right? At least mostly accurate, right? Without the detailed context, you cannot be 100% sure, but you need to try as much as possible, right? And make sure your arguments are logical, right? Fairness from different viewpoints. That's one thing actually very, very important. So I often see in our team project, you guys may find some customer that some very important segment, right? They say, hey, no, they are very valuable customers. We are going to focus on them. That is from one point of view, right? So you find one second of customer say, we want to focus on them. So how about other customers, right? Very, very often what I see is that the strategy proposed to help us engaging this most valuable segment customer will largely ignore other customers in the pool, right? Because what you do in this to this most valuable customer segment will be seen by other customers as well. Will they perceive it to be fair? What do they think about your strategies? Are you going to lose all other customers? And even from this most valuable customer, from themselves, right? What you do they receive this message? If they see they have a special treatment, what are they going to think, right? So that's kind of a look at the problem in different angles, which is very helpful, right? And try your best. Do not have huge gaps. Right? But we cannot fill all the gaps because in reality they're all problems, but we should try as much as we can to find the possible gaps that we have not addressed using our proposed arguments. Right. So that is critical thinking. I think it's worth your time to carefully go through this session. You will find it very helpful, not only for this course, but in other assessment or the way you deal with problem. Definitely worth it. All right. So talk about customers. That's our topic today. We spent the last few weeks about understanding what customers want, the value to customers, right? But we do business is not a non-profit organization, right? We want to harvest the value from customers as well. So this session we are going to talk about the other way around, right? So how we can get value back from customers, and how valuable is each customer to us. So first, let's clarify a view of looking at our transactions with customers. Right? So what the picture here is a traditional way, transaction view. So basically, now if you need to cost some money to get a customer, right? Sometimes it could be quite cheap. Sometimes it can be very expensive. But let's say in this case, it costs you $100 to acquire a customer. But by selling a product to the customer, you can only make $40 profit. Deal or no deal? Are you going to sell this to this customer or not? And if this is what your view now, definitely not, right? So basically, you're looking at losing $60. Right? But if you look at this problem from another angle, let's say, I want to not only just sell this product to the customer once, but keep a good relationship with this customer, right? So we talk about the history of marketing. Since 1990s, we learned that keeping a good relationship with customers are very important. And why is that important? This gives us a view, right? So we can sell sell something to customer. Right? We can keep on selling in the future. Right? So for the first time we make $40. Second time we make another 40, right? Third time we make another 30. We start to making profit, right? If we keep on selling products to customers, that will be good, right? So this is the base profit. But on top of this base profit, you can have other benefits as well. Right? So let's say, use an example. Say we have a lot of restaurants on Anzac Parade, right? So some new restaurants, they offer some lunch, let's say, right? So they have to offer some promotion stuff, right? $10 cash back or very cheap, very good price for me to get in there. So for the first time, they will lose money, right? On the acquisition cost, and the make profit they make from my lunch does not justify the first transaction. Right? But if I go there again, and 3 times, 4 times, then they start to make money. That is a base profit. But no, I may not only go there for lunch. Maybe I go there for dinner as well, or I go there for used to go there once a week, and then I decide to do it twice a week. Right? So that you will see the demand can increase. Demand can increase. Right? And they may charge some price premium. For example, if other there are new restaurants coming out, they're all offering very good price. If I'm very loyal to this customer, it's less likely I will switch to other restaurant, right? Or if they start to increase the price a little bit, I may decide, no, that's okay. I understand. I will not leave. Right? That's more likely to happen if I'm a loyal customer. Right? And the cost of saving. Right? Cost of saving is not very straightforward, but it does exist. Right? Thinking about a restaurant, you one of the valuable assets is their space. Right? They have very limited space over there. They can have a limited number of customers every day. Right? So if a new customer goes there, for example, I go there, I need to study their menu, right? Study the menu. I will spend an extra 10 minutes sitting there studying the menu. And that perhaps means one less customer, right? And if I'm an older customer, I know what they are offering, and I go there and I'll tell them, I don't even need to look at the menu, right? Tell them what I want to eat. That will save them some valuable table time. Right? And that also happens in other cases. For example, laptop, right? Those electronic products. A new customer is not experienced, so I will have a lot of questions how to use your laptop, right? So I will call them. I will call them to solve my problem. That all costs money. They need to pay people to sit there, talk to me, have solve problems for me, and that is could not be very cheap. Like a country in Australia, right? Labor is very expensive, and you can cost a lot of money on that. Right? But if I'm an older customer, I have already solved all these problems. I don't need to ask again. Right? I'm very experienced, so you will save a lot of cost from that as well. The relationship value. Now, I may say good things about your product or service. I may recommend your product or service to other people. Now, even I will take a photo of my lunch, for example, right? And put it on my Facebook or WeChat, other social media. Then my friends will not know about it. Right? So that's all the value you may get from a long-term relationship with customers. And this is indeed true for many industries. Right? So some data collected from Rich Held and Sasa, they show that here's 4 examples. Right? For example, the most typical one is credit card. Right? You know, when you apply for a credit card, many credit card companies will offer very good deals, right? So if you apply for credit, we will give you $50 cashback, right? Something like that. So, but the money they can make from you is based on how much you use that credit card. Right? They will have a small percentage of all the money you use. So for most typically, for the first year, the credit card company will lose money, right? Lose money, minus $21 on average. But they still try their best, try to give enroll new card users, right? Because they start to make money from second year. And if you are with them for a longer time, they will have make more money from a card user. The other 3 industry is a little better. Right? They start to make money in the first year, but there's a consistent pattern. Right? When you have a customer with a longer relationship, you're going to make more money from them. Right? So that has been found across many different industries. And this is a shocking number I mentioned in the first session. Right? If you can reducing customer defection by 5% or increase their retention rate by 5%, that means you can double your profit. Right? Double your profit. And where can you double your profit? No, that comes from base sale, from demand increase, from cost saving, from price premium, from relationship values. Right? All these things can bring your value. And they did that calculation saying, if you just increase retention rate by 5%, right, you can double your profit. So if we divide the total value a customer can give us. We call it a customer lifetime value. Right? So when the customer is with us till this customer leaving us, right? And we did use this in marketing for a long time. So a customer, a dead customer, a customer dead. So alive, dead. When they're with us, they're alive. So we call it a customer lifetime value. Right? I don't think it's a very nice way to say it. That's what we did. You may call it active or inactive customer with us or leaving us. That mean the same thing. Right? But the concept of lifetime value have been widely used. Right? So people's total lifetime value. Traditionally, we can divide them into two parts: economic value and relationship value. Economic value is, we did this division mainly because we can calculate economic value, but it was hard to quantify relationship value. But nowadays, it's more and more like we academics, right? We are working hard to try to quantify how much relationship means, how much value it can bring to a firm. Right? So if you find out some way to quantify the relationship value, you can pool them with economic value as well and calculate customer lifetime value. Right. So we are going to talk about the economic value in the rest of the session. Right? But briefly, relationship value. Right? Reference. There's two similar words, reference and referral. Reference basically means, if other people ask me what this restaurant about, I will tell them some information, right? And I will share with them my experience, word of mouth, that kind of stuff. Referral is basically recommending to others, making other people actually their customers. Right? There will be other values as well, right? Like learning. Learning is more and more important because nowadays we talk about personalized product or service for customers, right? But how do you know what kind of product or service you can provide to your customer, right? You need to learn from them. And you do the learning much, much better if they have already been with you. If they are happy to with you for a long time, they're happy to give you more information about themselves, you can serve them much better. Right? And even in innovation, right? So Peter Drucker used to say there's two things in a firm, right? It's innovation and marketing. But now even innovation full of marketing, right? Like new product development. You see engineer play a smaller and a smaller way in the new product development procedure, but marketing basically is everywhere. Right? So innovation relate to relationship value as well, because from loyal customer, from an older customer who has been for a while, you can learn from their user experience. They may tell you what they think about this product or service. That gives you a lot of opportunities to improve, to innovate. Right? So it has value for innovation as well. So about the part we can calculate, we are going to calculate in this course. Right? That's what we do here. So economic value can be defined as the discounted cash flow. Right? Or if you are familiar with this financial term, it's called present value of the future cash flow. So it starts with expected revenue cash flow. So this year, this customer may buy $50 from us. Right? Next year, she might buy another $50. No, in the following year, she may buy 60, let's say. Right? So that is expected cash flow. Then there's a cost to serve this customer. So when she buys $50, there's a $20 cost, let's say, right? $20 cost. So the revenue minus cost is our profit. It's expected the profit cash flow. Then we adjust the possible risks. Right? But after we adjust the possible risk, that is discounted cash flow. Loyal customer. Right? What the lawyers do here is lawyer can increase the revenue, expected revenue. Yes, there may be this demand increase. Right? Maybe demand increase. It can lower cost of serving this customer. At the same time, it can lower the chance that this customer will leave. Right? So that is one major risk over here. So it will lower the discount we need to make for future cash flow. So all these efforts will increase the discounted cash flow. Let me talk about the risk adjustment. There are two major risks over here. One is customer may leave. That is a part we care most with customer relationship management. And the rate we use to quantify that is a retention rate. That is what we talk about. When you increase by 5%, right, you can double your profit. That's the retention rate. That is how, given all the customer here today, right, for example, in a year, what's a percentage of them will still be with us? Or for a particular customer, if this customer is with us today, how likely, what's the probability this customer will be with us in the next year? So that's the first adjustment. The second adjustment is many other business risks that includes financial interest rate, right? So most of business will borrow from bank, borrow from other people. You need to pay people. That part of money you need to financial interest rate you need to discount from your future revenue discount, future revenue cash flow. Right? So that is finance. Right? Your business may go out of business. So there might be some political risks, maybe COVID-19. Right? All these, they are out of your control, right? Including financial interest rate. Mostly it's out of your control, but they do exist. Right? You also need to adjust for such kind of risks. To adjust for second type, we use this discount rate. Right. So here it's mainly from financial interest rate and business risks. This is not the part that we are mostly interested in customer relationship management. We just need to include that in our cash flow adjustment. They are mostly given for the analysis. They're mostly considered as given when we talk about the analysis of customers. Moreover, now separate issue, discount rate is pretty hard to calculate. If you study finance, you perhaps already heard about that, right? And as a matter of fact, most companies don't know how to do that. So in reality, you will see many companies saying, well, let's use, for example, 10% as a discount rate. That seems the most popular way, popular percentage people use. It is not because discount rate is indeed 10%. It's mostly because now the firms don't know how to calculate it. Right? And from marketing perspective, it's a given risk. It's something we cannot do. Now, for something we cannot do, we are not so much interested in that. So just take it as a given and do the adjustment. That's the end. Right. So let's say we have this revenue we can make from customer in period I. Here period, it can be 1 year. Or if you want, it can be half a year. It can be 1 month. It's based on the unit of your analysis. So let's say here it's for 1 year. So for ith year, you can, let's just use period. For ith period, you can make revenue RI here. And you need to pay CI as cost. Right? So that gives you profit is RI minus CI. That is a profit you can make in period 1, period 2, period N. Right? So then you need to adjust for discount. This discount rate. Discount rate is R, and the discount factor for the ease of our equation, it is 1 over 1 plus discount rate. So it's called a D. In this equation, we assume this customer will be with us. So the retention rate is 100%. We will add one thing at a time to this equation to show you how customer lifetime value is calculated. So assume the customer will be with us. We only need to adjust for the discount rate. So here we go. For the first year, we don't need to adjust because we talk about the present value. Here is a present, right? So we don't adjust it. And for period 1, we need to adjust the discount factor for 1 period. But for period N, we need to adjust the discount factor for N minus 1 period. Hope you are very clear on that. So this part is the adjusted cash flow. Right? And we have another cost called the acquisition cost. Right? It only happens at the present time, at the very beginning. So customer lifetime value is a total expected profit flow, adjusted profit flow, minus the acquisition cost. That is how much a customer is worth to us. A question, what does N represent in this formula? N is the period, right? Like 1, 2, I, N. They just representation of period. So this is in a situation where customer will be with us forever, but we know that is not true. So we need to adjust this retention rate as well. Oh, here's an example for you. Right? So to help you understand better, let's say this customer can make us $25 every year. The cost is to serve this customer is $5. So we can every year we can make $20, 25 minus 5, 25 minus 5. That is the same for every year because revenue cost stays consistent. Then we need to apply for discount. For the $20 in period 2, for the $20 in period 2, we only need to apply this discount once. Right? So the $25 is worth, the $20 profit is worth 20 divided by 1 plus the discount rate. Right? Here we say discount rate is 15%, let's say. Right? So that is how much it is worth, the $20 in year 2 worth to us. Then in period 3, we need to apply the discount twice. Right? Yes, it's discounted to period 2, then discounted to period 1. So we need to discount it twice. Alternatively, you can see now based on year 2, you just need to apply discount, this discount factor one more time. Right? So similarly, in ith period, your $20 profit will be discounted for I minus 1 times. Right? So that is a situation where we have this customer forever. But now when we customer is possibly leaving, we have retention probability here. Retention probability. That is the likelihood of this retaining this customer in period I. Right? So you know, in the first period we have P1, right? But we know this customer is with us, so P1 usually equals to 1 here, right? And P2 That's something we need to talk about. Now, customer may have certain probability of leaving if we have him or her this period, right? So, and in the future, it's more and more likely this customer will leave. So this probability will be smaller and smaller every year. Similarly, we have revenue, we have cost, we have discount factor and acquisition cost. So the only difference is that for each period after this discount of, after the adjustment of discount rate, we add another probability. That probability is this customer is with us in period I, the probability of these people with us in period I. So in this example, we know this customer is with us for sure, 100%, right? In period 1. So period 1, it will be $20 profit times this retention probability, 100%, times this discount. So $20, no problem, right? The same amount we got before. However, given this customer is with us, there's only 80% of chance this customer is still with us in the next period. Right? So this customer is with us in period 1. We need to time this current probability with another 80%. So we got in period 2, we got 80% of chance this customer is still with us. So on top of this discount factor adjustment, we need to apply another 80%, because all this is only gonna happen if this customer is with us, and that probability, that if probability is 80%, right? So this is period 2. Period 3, given this customer is only with us with an 80% probability in period 2. The probability this customer with us in period 3 is even smaller. Right? Let's say increment of the retention rate. Retention rate is 80%. That is, if this customer with us in period I, it's 80% of chance this customer with us in I plus 1. Right? So we need to apply another 80%. That is 80% square, or 64%, right? In period 3. So you can see based on the discounted value we had before, we need to apply this 64%. This is because this amount of money is only going to happen if this customer is with us, and that if probability is 64% or 80% square. Right? So you can keep on do that. In ICE period, right, your retention rate, your retention probability is 80% retention rate to the power of I minus 1. Right? I minus 1. In period 2, right, 80% to the power of 1. Period 3, 80% to the power of 2. 2 is 3 minus 1. Right? So we keep on do that. And for the discount value you get in period I, you need to apply this retention probability. Right? And now you have your discounted cash flow after considering the possibility that people will leave. Right? So that is some example. Mathematically, here is the equation, but it looks too messy, right? If we make some further assumption, let's say all the revenues are the same, all the costs are the same, the probability of retention can be right in this way, just like what we did in this example. Right? And P1 is 1, because P to the power of 0. Right? P2 is P. Here, P is a retention rate. Retention rate. So Pn is P to the power of n minus 1. Then we can rewrite this equation into this one. And this equation can be beautifully rewritten as this one. So here's the calculation procedure. I'm sure you know it from your high school. But if you forget, this is a quick reminder. in this course, I have no intention to break now to talk about this math again. But in case you're interested, here you go. So after this calculation, when we assume n goes to positive infinite, you can transform this part into this one, because when n goes to infinite, this number, which is smaller than 1, will go to 0. Go to 0. So you can rewrite everything here. If I replace the discount factor with its original equation and put the discount rate back in there, you can have this equation. That's where you will nicely see this CLV calculation formula. Right? But since we did all this calculation, you need to know, right? Although this looks very elegant, nice, we have made a huge number of assumptions over here. Right? That is, revenue every year is the same. Right? But now you will say, something you promised that the revenue will increase, right? And the cost will be the same. You talk about the cost will reduce. Right? And here now, discount rate, well, that we out of control, right? But retention rate, P, retention rate P, it may increase, right? When this customer is with us for 10 years, it's more likely this customer will be with us for another year, right? Whereas in the first year, that retention rate is a big question mark. Right? So all this can change, but in this formula, we assume everything to be the same, right? In order to get this very elegant looking equation. But don't worry too much. I will give you another model that we can use to accommodate all this revenue increase, cost decrease, retention probability increase stuff. Right? We can do all of that. Right? So, but let's first do a quick exercise. Right? So you have already get this equation. Please do this calculation. Right? The cost is $15 to acquire a customer. So acquisition cost is $15. A cost to serve is $5. Revenue is $25. Discount rate is 15%. Retention rate is 80%. What is CLV for this customer? Right? I will give you 1 quick minute to calculate that. Have you got it? This should be very straightforward, right? So we have a question. Why do we have n approach infinity? Right? Why do we have this one? Because our calculation is customer lifetime value. By lifetime, we assume n goes to infinity. But no, it's arguably customer cannot be with us for more than 100 years. That's totally possible, but this is a mathematical treatment. And with Excel model, I will show you, you will find actually the number of n does not have to go to infinity to make this part 0. Right? After 10 periods or 20 periods, this is virtually already 0. Right? So it's a mathematical treatment, but don't worry about with that number too much. So this is a calculation, right? So just put all these numbers in there, discount rate, retention rate, and all this number, $50.71. So in this equation, you can see that when your revenue increase, your cost decrease, your customer lifetime value will increase, right? And the probability of retention, right? The P here, if P increase, right? If P increase, the bottom part will decrease because there's a minus over here, right? And when the bottom part decrease, the entire this part will increase. And because that increase, CLV will increase. That in English, if you increase customers' retention rate, your CLV will increase, right? Will increase. All right. So in the next half of the today's session, I will show you our Excel model, which addresses this caveat I talked about. But let's take a 5 minutes break, and we'll come back and talk about this Excel model. All right, welcome back. So a question about the quiz. So for quiz, we need to download a data set for the assessment. Yes, you do. And data you need to download is right here, right below the quiz instruction. So we are going to use the Excel add-in to do some analysis over there. So before your quiz, make sure that you have your Excel add-in properly installed. I noticed that so some students tell me their own laptop may sometimes have problems with Excel add-in. So if you are worried, I would recommend that you can go to the computer lab. There's Quad G021, the computer lab that is open for you. That's where our face-to-face sessions happens. So the computers there, they recently have a new set of computer, all quite stable. We didn't have any problem install and use the software add-in over there. So if you're worried about that, you can do quiz in the computer lab. But no, most of the time it will be fine. If you have already been using your own laptop for all the exercise we have done, you should have no problem. I also have some troubleshooting hints for you. At the installation file, check it if you are worried. So in case it goes problematic, you can just kill the process and restart it. Most of the time, it will solve the problem. All right. So now we go back to today's topic, and I'd like to show you the Excel model. So this is a model we want to set up. So Excel model, we are going to do the CLV calculation period by period, just by definition, as the two examples I showed you. And this procedure will show, hopefully, make your understanding of this CLV calculation much better. And with this model, you will find that we can easily adjust the revenue in the future, the cost in the future, retention rate in the future. It will be very easy for you to calculate. So here, first we need to fill in some numbers here, right? So the revenue is $25 per period. Right? Cost is $5. Acquisition cost, if I remember correctly, it's 15. Yes, $15. $15. Discount rate, it's 15%. Right? Retention rate, let's say it's 80%. Right? So with all this, you can already calculate this. Use formula, you can calculate CLV, right? Let's do that as well. You should be able to do that, by the way. So 1 plus this discount rate, right? Divided by 1 minus retention rate plus discount rate, then times revenue minus cost. And don't forget this acquisition cost, right? $50.71. That's exactly what we did, right? So for this Excel model, this is just a formula. Now let me show you the Excel model. Excel model is about doing the period by period. So for the first period, like in the example, right? We know this customer is with us, so probability is 100%. Revenue equals to this one. Here I want to lock this cell C2 in this equation because I will copy this to other periods. So I press F4 to lock it. Cost equals to this one. I will also press F4 to lock it. Discount for the first period, right? We don't need to discount anything. Right? So the discount value equals to the first profit, revenue minus cost in a bracket, times the probability, right? First probability times this profit and times this discount, total discount, that is $20, no problem. Right? So that is period one. Then the second period, we talk about retention rate. The retention rate is given the probability of this customer with us or this customer is alive. What is the probability in the next period, right? So basically, based on the probability this customer is still with us, we need to time the retention rate. Here, you need to note that I don't want to lock the C11 because the last period, when I copy this formula to other period, the last period can change. So I don't want to lock it. But the retention rate needs to lock. I don't want this one to move. So you have 80%. Revenue, that is the same. I copy down. Cost, the same. Copy down. Discount. Discount is also similar to the total likelihood. Right? The total discount is how much we discounted. And we discounted again, right? Discounted again. So we times 1 divided by 1 plus the discount rate. I also want to lock the discount rate, right? But not the total discount in the last period. Right? So here's a discount, total discount in period 2. Discount value is still the same, right? This probability times revenue minus cost times total discount, right? So you can see for the second period, it's already $13.91. A lot less, right? A lot less than the first period because of all this discount. You will be surprised to see what happened next, right? So let's try another period. In period 3, based on the probability of this customer still alive, right? In the last period, we times another retention rate. See, only 64%. Revenue and the cost is the same. Right? Discount factor is how much we discount last time. We discounted again. Right? 1 plus this discount rate. From a discount value calculation formula is the same. Now it's just a 9, right? And if you keep on copy that to 10 period, you see it's less than $1. Right? After 20 period, it's just 2 cents. Right? So we really don't need to consider this N. Right? In the question we had in the last hour, right? This N. We really don't need to worry about too much. It will quickly go to a very small number. So we do that for 100 period. You see now, for after like 24, it's virtually 0, virtually 0. So the total CLV here, I want to sum all the discount value together, right? All the discount value together. Then lastly, minus this acquisition cost. So that is our CLV calculation. You see, although we go through all these steps, right? The total calculation is exactly the same because assumption here is the same as the formula. So that's how we get this CLV model, Excel model. But it has some certain advantage. Right? First, you see what you get step by step. Right? You can do some simulation, right? And visualization. Right? Let me show how. Right? So here, let's say I'm interested in finding out if I change my retention rate, what will happen? Right? Retention rate is here. Right? But I want to do a little bit fancy stuff, you know. I can click something and show how it changes, right? So let me do that. So I will go with this developer ribbon. If you don't see that, you see now when you have this option, right? Option, you will go to customize ribbon. I believe for many of you, this is unclicked. Right? So you want to use it, you click this one and click OK. Then you will see this developer ribbon. So I want to insert a form control. Right? Form control, I want a scroll bar, right? Scroll bar, yes. I want a scroll bar. Okay, scroll bar. And I right click on this format control. Right? I want to link this scroll bar to a cell. Let's say this one. The count value, instead of 80%, I set it at 80 because for this scroll bar, every time you click, the minimum step is 1. So instead of so every time I want to set it in a way, when I click this, the retention rate will change 1%. Right? See how I do it. Right? So a count value set it to be 80%. The minimum value, let's say it's 60%. 60%. Right? No, that could be smaller. Let's say just use 1. Right? Maximum value, of course, is 100 because 100%, that's the ultimate thing we can have, right? And we say, okay, great. So here, now you have this scroll bar, you can move, see? If you click on that, this number will change 1 at a time. Right? With that, this retention rate, instead of fix it to be 0.8 or 80%, I set it to be this new number divided by 100. Right? So in that way, I have 80%. And every time I click 1, here this number will increase by 1. But as a result of the retention rate will increase 1%. And I can, now I can show you every time I change 1%, how the CLV will change, right? So I will change it. See, every click, you will see the retention rate will change. Right? And if I increase retention rate by 5%, what will happen? It increased from $50 to $61. Right? It's already like 20% increase, but it's not 100% as I promised you. Why? Because we only considered the retention rate itself, but did not consider the other byproduct with loyalty, right? With loyalty. For example, the revenue will increase, the cost will decrease, right? And we can, I will show that in a minute. I will show that in a minute. So first, let's say, keep it back to 80%. So that is a simulation and a visualization that we can do, right, to make your worksheet a smarter one. Right? And you can think about it. If you present this to your team, right, to your team, maybe your customer or supervisor in your work, now you can do something like this. I'm sure it will be pretty impressive. Right? We can also do some sensitivity analysis. That is create a table that shows if I change retention rate or discount rate, right? What will happen? in this table, you can see now, if my retention rate is 80%, discount rate is 10%, let's say, right? So the CLV should be $58.33. But if the discount rate is 12%, it will reduce to $55. Now you may ask, now Songting, you just told us discount rate is given. Discount rate is given. It's not our focus of customer analysis. Why do you still want to see the sensitivity across discount rate? If you are thinking that question, I think you are paying good attention. Right? But the thing is that because discount rate is so hard to calculate, people will have different opinions. So you may think, you know, 10% is good. Other people say 15% is good. Someone will say 20% is good. There's no point arguing who is right. But with this sensitivity analysis, you can virtually show people. Now, well, if your assumption is correct, what will happen, right? So given our retention rate 80%, if you believe that discount other business is not very risky, right? So the discount rate is only 10%, then it means our customer, this customer value, lifetime value is $58. But if you believe our business is in risk, 16%, let's say, discount rate, then this customer lifetime value is only worth $49.44 to us. So instead of saying, because no one knows, very few people knows, very few people can accurately calculate discount, right? So you can just show people, now, given all these assumptions, what will happen in that scenario, right? And how do we do that? This is our table, right? So this part is what we are going to work on. Here the trick is, right, on the top left part, this cell need to have the formula, right, that you are going to use. So in this case, it will be this formula that I want to use. Right? So make sure you first select that. Then you select this entire sensitivity analysis table. Right? You go to data, this data ribbon, right? Data ribbon. There's a what if analysis, right? And there's data table. That's what we want to have. Right? The data table. So the raw input cell. First, you need to specify two cells. That is where all these numbers are from. Right? So in this formula, I want to change discount rate. Which cell should I change? Right? I want to change the discount rate with 10%, 12%, 16%. Where should I change? You should tell Excel, now this is a place. Right? C5, that's a place you should change. Right? And when I change retention rate, 60%, 70%, 90%, which cell should I change for this formula that I quoted? Right? Now, this is the cell you should change. Right? You click OK. Here you go. Right? Here you go. You can easily change this, show this sensitivity analysis. Right? And on this table, you can even make some further adjustment. For example, I'm thinking about 15%, right? We talk about 15%, so let's do 15%. It will do it automatically for us. Right? So you can see the formula, basically the entire table is set in a way that when you change some retention rate, for example, here 0.85, right? What will happen? It will calculate automatically for us. Right? So that is sensitivity analysis. Now, lastly, what I promised you, right? Accommodation, it can accommodate the loyalty effects. For example, growing margin. What if I want to have different retention rate, different discount rate, right? So let me show you where this double profit come from. So let's say for from the second year, right, my revenue will increase every year by $5. Right? So in this table, I can set it in a way. So the second year, the revenue is the last year plus 5. Right? Can I do that? Right? So I can do that for all the following period. Right? You will see it grows pretty large later, but actually it does not matter too much. Does not matter too much because after a few years, even huge number, right, it will go to like 0. So don't worry about that too much. Cost, it can reduce cost, but you know, our revenue increase. So I will assume the amount you need to serve customers should increase as well, right? So let's say the cost will change a bit. Let's say 50 cents because revenue basically increase $5. That leads to $1 cost, right? $1 additional cost. But we say now there's some cost saving, so costs only increase 50 cents instead of $1, which should increase, right? Based on revenue. So let's say that's the thing. Right? That's the thing. And retention rate. Now we change retention rate. You see in this Excel model, we can easily adjust the revenue in a certain year. Right? We increase retention rate from 85%. Right? Now you see your CLV is $110. Remember last time is $50.71, right? And that is indeed double the profit. Right. So percentage, right? 218%. So that's how you increase your retention rate by 5% and double your profit. Similarly, now if I say that the retention rate, right, discount rate after 10 years, our business will be quite stable. Let's say after 5 years, currently discount rate is 15%. But if our business can survive for 5 years, right, from 6 years, the discount rate is no longer 15, but 10%. All right. So how do we do that? So we say now from the 5th year, now when we apply a discount factor, we do 1 plus, not a 15% here, we have 10%, right? 10% instead. And we do that for the following years. So, you know, if our business become more stable, what's the effect? Right? You remember last time it was 110, right? So it will change from $110 to $122. Right? That's the benefit of our business becomes very stable after 5 years. Right? But that's a kind of out of our control. Right? Just to show you some effect as how this can do. It does not mean you're going to you have to do that. Right? So that is another thing we see from Excel model. Right? Any questions so far before I move on? By the way, now all these things, I have this solution file for you as well. Right? So if you are not did not quite follow what I did here, one thing is to check my recording. Make sure you can do it yourself, but you have my solution file to compare with. All right. So yes, there is a question. Can you explain the discount rate variable? Sure. Discount rate, I think it's best we go back to the previous slides. Right? So the discount rate is the risk with the business. Right? So your business may go out of the market. Right? You also need to pay financial interest rate. That's where you learn present value in finance. Right? And there may be other risks like political risk, COVID-19. Right? These kind of risks all affect how much a customer is worth as present value. Right? but it's out of your control. So we mostly take it as given. So the question is, no, it's not a shopping discount. In the real world, it's hard. I know it's hard to explain it in the real world, but it does exist in the real world. COVID-19 is a very vivid example of some risk that we don't expect, but it exists. How is it quantified? You should learn that in your finance course, not my course. But this is very hard to calculate. And different people, virtually it's a subjective call. For example, how likely is our business going to go down? Who knows? It's a subjective call. And it does not bother us because we are only interested in customer side. We take this as given. All right, individual or segment level estimation. Individual staff level estimation is more and more important nowadays. But now what we have achieved so far is aggregate level. We assume everyone share the same profit, share the same cost, share the same retention rate, all the same for everyone. But we know now different people have different retention rate, for example. They may generate a different revenue for us. How are we going to accommodate that? The model we can use is exactly the same. We just say now in the Excel model I just showed you, right? We didn't say it have to be a retention rate that is average from the entire customer pool. It can be just one person. It can be from the average retention rate from one of the segments. It's all doable. So model-wise, it's pretty straightforward. You just replace the average retention rate, the average revenue cost with the individual retention rate, individual revenue and cost, or segment retention rate, segment revenue and cost. And you can also adjust acquisition cost, right? But now discount rate, if you want to apply for different segment of people, you can. The same logic is the same, but it's since this is basically business risks, I would assume in most cases it should be the same for all segments. When we talk about individual level prediction, this part is critical. So it's logically you need to understand what we talk about individual level. Most of the time, it's not about one particular individual. For each individual, if you want to predict what he or she wants, what he or she will do, it is very, very difficult. Even with this so-called big data approach, it's very, very difficult because there's limited observation for each people. Limited observation. And when we do observe their behavior, there's limited information we have. For example, we observe our customer buy some product, but what is a consideration set? What is the potential options that this customer faced? Right? For example, you may see I buy product A from ABC. Right? Another person may buy product C, but that person may choose among product C, D, E. Right? I choose between A, B, C, so I choose A. The other person chooses from C, D, E, so he chooses C. It's not necessarily mean me and that person is different. Maybe if he's having the option set A, B, C, he will choose A as well. But we don't know that, right? Based on the information, Songting chooses A, that person chooses C. These two customers seems to be different. We don't know. right? Maybe their preferences are the same, right? So, but we can do some research study like content analysis, right? We can ask each person a lot of questions, have a thorough understanding of what they do, but that most of the time is not possible. Right? But for all potential customers, it's not possible. Right? So even with a big data approach, right, what we essentially do is pooling a huge number of customers. So, and we assume that customers with similar, we assume we can find a set of variable that is able to represent some latent traits of a customer. Right? And that latent traits decide which product this person will buy. Right? And by doing that, we are assuming that the customer with the same value for this set of variable will behave similarly. Right? For example, say I use a set of variable, income, education level, whether on a credit card, whether I have a car or not. Right? Use these 4 variables to find out, to represent this person's latent traits, right? And they use that to predict whether one person will buy or not. Then 2 persons share the same income level, same education level, both on a credit card, both on a car. You will predict exactly the same for them. Right? It's true that when you use, for example, 100 variables, right? Such kind of variables, like many big data approach, then you will find the set of people you identify when you set value for these 100 variables. It can be extremely small, right? Sometimes maybe only 1 person in there. Sometimes maybe one or two. In that case, it may happen to be 1 person. You're indeed predicting this 1 person, but the logic behind that still don't change. It's talk about where I'm interested in the purchase likelihood, right? So I'm talking about the purchase likelihood of a customer like this person who share the same value for this set of variables. I talk about the amount a customer will likely to buy, a customer who like this person. This is true logic behind individual level estimation. So virtually you can think of, you use some variable to create some segments, right? And when you use more and more variables, the segment becomes smaller and smaller and smaller. In the end, there may only be 1 individual in that segment, right? Things like that. So segment level estimation is that we don't have to identify customers too much, right? We can just simply classify them into a few segments, for example, 2 or 3 segments. And we assume that the customers within that segment, they are similar. Right? And the customer from different segments, they are different. This will be very helpful for us to now understand customer, predict their customer lifetime value, calculate for them. For a few segments will be much easier for each individual, right? But at the same time, we accommodate some customer heterogeneity. We acknowledge that some customer group will be different from others, right? And that is very helpful. And in the next session, right? In the next session, we are going to talk about segmentation. We're going to use class analysis tool to help us segment the customers, right? And then when you have those segments, of course, you can follow up, do some additional analysis, just like calculating customer lifetime value for a particular segment, right? And you will find it very helpful to understand how customer lifetime value are different across different segments so that you can make marketing strategies accordingly. All right, so how about the following information? All right, so we have talked about the discount rate as already. So expected individual segment cost, acquisition cost. Now they can all be different. And the reason I asked this question is that we well, actually, I have a later slides for that, so I will keep it for now. I have a later slides. We will talk about this for our team project. I mainly want to ask you this question: how to implement customer lifetime value, if there's any way. So let's look at the next slide first. Individual level customer lifetime value. If you want to estimate that, right? Or if you want to find some potential segments for customer lifetime value, right? What kind of variables might be useful to do that? Now here's one more assumption. This is marketing theory, right? So based on theory, logically thinking, we believe that a customer's historical purchase behavior can be a good predictor for his or her future purchase behavior. Does that make sense? Right? This makes sense, right? So when you have an argument, you ask yourself, does it make sense, right? So if we agree on that assumption, then we can further think what kind of historical behavior can be used, can be used. Here I list of three. These three are high-level summary of all these transactions people make. That may include recency. What is how long it has been since the last time this person buy from us? Right? Frequency in a certain period. Right? In a certain period, for example, in the past year or in the past half year, 3 months, right? How frequently, how many times this person buy from us? And amount, purchase, monetary value, right? Monetary value. So in a certain period, 1 year, 3 months, half a year, how much in dollar value does this person buy from us? These three features, based on many people's experience, they're good variables that we can first easily summarize from people's past behavior. Then second, they are very useful for us to predict their future behavior. So if you did my exercise in the last few tutorials very carefully, you perhaps start to know why I ask you to do this counter if s, sum if s. These functions are all useful to summarize this historical purchase behavior. So make sure you know how to do that. Then how to use this? I used to introduce some outdated model for you to better understand these RFM variables, but I found it caused a lot of confusion. So I simply drop it. So I simply drop it and show you what I think is the right way to use these variables. Suppose, let's say, I want to estimate individual level, do some individual level estimation, to calculate customer lifetime value, right? I need to calculate the possible revenue, right? Revenue, cost, retention rate. These are all the things I need to calculate before I can do customer lifetime value, right? So I first say now, what is amount a person will buy from us? So the dependent variable is in the next year or next period, the amount this customer will buy from us, a customer will buy from us. So this is a dependent variable. You see, I use regression again. I use a regression again. in marketing analytics, even when you get very, very complicated models, at the end of the day, you will find that we are still using this logic from regression. Regression is a very important tool, and the basic logic for many complicated tools as well. So you need to have a thorough understanding of this kind of relationship. Right? So basically, by this equation, I'm saying this dependent variable I'm interested in, it is related to, it can be explained by these three historic purchase behavior. Recency, frequency, monetary value, they are independent variables. But pay attention to the period. So they are from previous period. Previous period, they will predict how much this person will buy in the next period. Right? So after you calibrate this equation, then you can calculate. If I know the RFM in year M, right, then I can predict what will happen, how much this person will buy in year M plus 1. Right? So that is purchase amount. Likelihood, right? Likelihood, buy or not to buy, with us or not with us, active or not active, right? So that kind of dependent variable, when I talk about, you know what kind of regression you are going to use. Right? It's a binary logistic regression you need to use. So the dependent variable is buy or not to buy. Right? Probability is a very abstract concept. So you cannot have probability data easy. Right? So you use logistic regression. But with logistic regression, you can calculate the probability after you calibrate this equation. Right? And we will do that in the tutorial this week as well. Right? We are going to calculate the probability of a person will buy or not, or will not buy. So this binary logistic regression can help us answer this research question. Right? Dependent variable is buy or not to buy, active or not active, live or dead in the next period. The independent variable is the same. Now, in the previous period, what is RFM? Recency, frequency, monetary. And this regression says, now I assume whether people buy or not can be predicted by their RFM variables. So with this calibration, you can predict the purchase likelihood in M plus 1 year, if you know the data from year M. Right, you can have, this is just a basic regression, right? You can have better regressions, like this one, right? I not only know this person's RFM, I also know this person's gender, age. If I believe these additional variables can help me better understand, better predict whether this person will buy or not buy in the next period, well, I incorporate them in my regression, right? The regression has a great feature that you can extend your equation to incorporate more information. Now you can, of course, this part you should know how to do that, right? There's some optional part. If you are familiar with nonlinear forms, right? You can think of adding some quadratic terms. If you assume the impact of monetary value towards buy or not to buy is not only linear, right, but could be nonlinear. For example, it can be convex, right, or concave, or then you can incorporate some quadratic term, right? If you assume that impact could be S-shaped, right, or inverse S-shaped, then you can even add a cubic term in there, right? So that is up to your understanding of the problem and your imagination, right? But certainly you can incorporate those information to enhance your regression. Now we also talk about the dummy variable, right? If you believe people's behavior pattern is like here, right? If you believe that people's frequency can be classified into 4 categories. And people with 4 categories, they are different across different categories, but people within the same category, they should behave similarly. Then you can use 3 dummy variables, 3 dummy variables to classify these 4 categories. For example, I believe people have a frequency less than 50 times, they should behave the same. That means if people buy 1 time and 20 times, 30 times, I treat all these 3 people to be the same, right? And then now 50 to 100, 101 to 200, larger than 200 as 4th category. Then I can, with 4 category, I can use 3 dummy variables, right? 3 dummy variables. The number of dummy variable is always 1 less than the level you're interested in, right? So I use 3 dummy variables to do that, to identify now this category. Let's say the first one is category frequency 0, right? So this is frequency 1, frequency 2, frequency 3, each with 1 dummy variable. And I can incorporate these dummy variables in this regression. That represents nonlinear as well. It's not just some S-shaped or something. It's like stepwise kind, right? For example, if this is the effect of frequency 0, and this is frequency 1, right? This is frequency 2. This might be frequency 3, right? So you can see the stepwise shapes over there. Right? But now this is kind of optional. I gave you these hints so that you may be able to incorporate that in your own assignment. Right? It's all open up to your imagination. Right? Next one is also optional, where I will show you some very good predictive performance generated by stochastic model, some stochastic model. So stochastic model is using, assume all the variables follow some sort of distribution. Right? And instead of using a typical linear regression, I manipulate these parameters in a distribution to represent the relationship I want to achieve. So this equation, expected value of customer lifetime value is equal to this part. Now this part may look scary, right? But now if you're familiar with math, basically it says, add, so each thing here is a result from 1 period. I just add things from period 1 to period infinity. Right? That's exactly what we just did in the Excel model. Right? It's the same. Right? But this is a finite degree, right? And the distribution of all these variables is much more flexible than what we just did in the Excel model. So here are 3 parts. V, value, that's a cash flow at time t. And ST is a probability that a customer is alive, is active at time t, and D is just a discount factor. And so we use 2 distributions. 2 distributions. Here, V is a gamma distribution. Right? So basically, the value follows a gamma distribution, and one of the parameter, which is scale parameter, right? Its scale parameter follows another gamma distribution, right? Which is very complicated distribution. If you Google it, Google the gamma distribution, you can find that distribution is a positive value, right? But it is a very flexible distribution. And by applying the scale variable to follow another gamma distribution, basically this can represent anything positive, right? And the live probability times the discount rate. So basically the total discount. The total discount is modeled by a Pareto model or MBD model. So basically this purchase frequency follows a Poisson distribution, or its interpurchase follows an exponential distribution. Then the coefficient, the gamma, right, follows another gamma distribution. Coefficient lambda follows another gamma distribution. So all very, very flexible settings. This is performance. Right? So first I predict the frequency. Right? So this is from this paper in 2005. Even though it's like 15 years ago, the performance was already great. Right? So here is a number of real transactions in one. They did some study using 7 to 8 weeks of purchase data, cut it into half, right? So use the first half to predict the second half. Right? So number of transactions in week 1 to 39, predict the number of transactions in the second half. The solid line is a real predict curve. Right? So dashed line is a prediction, right? Which is almost identical, right? Perfect. Here they also predict the expected monetary value, the amount of purchase. Right? Two things we are interested in, right? To calculate the customer lifetime value. Remember, right? So, so this is their final prediction of customer lifetime value (CLV). Right? This is 3D, so look a little bit complicated. Let me quickly introduce to you. So here, these two horizontal axis. From this direction is more frequent purchase. From this direction is more recent. Right? So we would generally think that if a customer makes more frequent choice, if a customer more recently buy from us, this customer should have a higher customer lifetime value, right? And that is indeed true. Right? As you can see, it's when it goes to more that direction, this hill, right, grows higher. Right? So if I like smash the left part onto this 2D dimension, so I get the chart on the right-hand side, I will find that indeed the case. When it's more frequent, more recency, the customer lifetime value is higher. However, you may notice something over here. Right? So this is indeed what we expect. If you notice something here, for this customer, right, with low level of recency, whose customer lifetime value is higher? Is it a very frequent purchaser or not so frequent purchaser? It's actually this group of people whose frequency is not very high. Their customer lifetime value is higher. That's something interesting prediction, right? And the reality actually happens to be like that, right? And there's reason behind this. The English language here is, for those people who we have not seen for a while, that recency is low, right? So for those people whose recency is low, we haven't seen them for a while. If a customer is a low frequency purchaser, then there's still some probability this customer will come back and buy from us. But if this customer is a very frequent purchaser, and we haven't seen this customer for a long time, that means we have already lost this customer. Right? That's straightforward, right? So it actually makes sense. Right? This argument make logical sense, but if it helps us further understand what we are dealing with. So this stochastic model, they are good to fit model. Only a small amount of data will be sufficient. However, they are not very popular in marketing because they do not consider marketing decision variables. That's one thing. Decision variable means, now what if I do something? I don't just want to know what people's customer lifetime value is. I want to be able to say, if I do something, will their customer lifetime value increase or not? Right? If I did something wrong, how much their customer lifetime value will drop? right? That is very helpful, right? So this stochastic model or use distributions, they are not able to do that too much, right? Second is this assumes market does not change. It does perfectly when the market does not change. But if there's some change in the market, then you basically cannot use previous market status to infer the current market status. All right, so that's the pros and cons of this. So now our final discussion. Right? So now that we know how to calculate CLV, how does it help us with marketing decisions? Right? That's what I actually just mentioned. We want to be able to do something. Right? So we calculate the customer lifetime value. We have the ability now, right? But this is not at the end of the story, but just the start of our journey. Right? So we want to calculate the customer lifetime value for different customers. Right? So we understand the customer heterogeneity. We want to understand the customer lifetime value given different things we do. So we know how our marketing strategies is going to impact the customer's lifetime value. Right? Then you can make a decision as what I want to do, right? So that is how you are going to use it, right? So next question is now customer lifetime value seems to match our team project very well, this concept, right? But in our team project, we don't have cost information. We don't have cost information. We don't know acquisition cost. We don't know this the cost to serve customers. What should we do? Does that mean we cannot estimate the customer lifetime value? Right. That is a question I often got asked by students in the previous term. So the thing is that you can still use this customer lifetime value, but you need to twist it a little bit. Right? Here, when we talk about customer lifetime value, we are calculating the discounted profit. But if you don't know the cost, basically in this customer lifetime equation, right, you set the cost to be 0. Then what do you calculate? You can still calculate the equation. You can still calculate this Excel model. Simply, when you don't have cost information, what you get is your customer lifetime sales, right? Get that? Right. It's just you cannot calculate profit, but you can still calculate the sales. Will customer lifetime sales be helpful? Of course it is, right? Well, first, it's better than not knowing anything, right? Second, in most of time, actually, you don't know a firm's cost structure unless you are doing some internal consulting project. If you are a third party, you are working for a consulting company, it's very often that the company will not tell you their cost structure because that's kind of business secret. Right? But on the other hand, if you are in a firm, if you are the manager, you definitely know that cost structure. You know that every dollar you sell, how much profit you can make. Do you? Right? It's natural. We are all thinking of how much money we can make, right? So every year we make how much profit and what's the percentage of profit we can make, right? You tell me, I can calculate right away. You tell me this customer's lifetime sale is $100 and my profit rate is about 10%. I instantly know that means $10 customer lifetime value. I know that, right? So without knowing cost information, you can still use that, but now your argument and the calculation, you need to have a little bit twist. Right? So that's kind of some flexibility. Right? In one course or even in a lot of courses, lecturers cannot tell what you can do in all the situations. Right? I teach you this tool, and it's up to you how to flexibly use it for your own situation. Right? Every time you need to adjust a little bit to make it work. Right? So that's why our work is valued. Right? If all the problem are the same, then they perhaps should not hire you, right? They should just hire someone now to program the system for once, and everything is solved. Right? But because the world is very complex, because every time when you implement some analysis, you need to make subjective adjustment. That's why your work is valued. Right? That's why they need to hire people like you, right, to do analytics for them. All right. So don't forget to do the quiz this week on Friday, and a team project. I expect to see your research plan soon. Right? In order to help the tutors go through your plan before the discussion, so we can have we can prepare to give you feedback. So make sure that you submit your slides by Sunday. By Sunday. Otherwise, next week we are going to talk about the segmentation. We already talked about the use of segmentation a little bit this week. So I hope I got you excited. Next week I'm going to show you how to do that. In the next tutorial, we are going to discuss a quiz and discuss the research plan with your presentation. Question, quiz, yes, it's multiple choice question. For all this assessment, I have detailed instructions for you. To do well in this assessment, I think it's definitely beneficial for you to go through my instructions very carefully. All right, so that's all for today. I will see you next week. Bye now.